very out of time. I don't know, maybe we can allow just one question if we add it. Do we have some questions? No? This is not the case, so we can go on.
Thank you, Professor. So we move to our last speaker of the day that I have the pleasure to introduce. No, of the day, sorry, of this session. Okay. This morning session. So Pierre-Philippe is the only blockage that is between you and the coffee.
So vicious.
No, I will stand up. Is the slide there?
Yeah?
Yeah. So in the meantime, I'm honored to introduce also Pierre-Philippe. He's a colleague, so he's coming from ESA as well. He's coming closer, from a closer location. It's just nearby ESRIN establishment of the European Space Agency. Pierre-Philippe is one of our leading scientists. He's working in the Earth Observation Department, but he's a scientist, so he's well titled to talk to us about open data. And so the experience that is bringing to this in terms also of access to this data. Pierre-Philippe, you have the floor.
Okay, thank you very much, Luca. So this is a cartoon from my daughter following a competition of Copernicus here in Italy. They didn't win, but some of their fellow in the same class won. And I wanted to show them their piece of art because they were asked what is Copernicus, which is a system for monitoring the environment, telling you. And for them it was very simple. It was like making a selfie from space and having a permanent selfie to protect our planet. And you see here that the Earth is very happy to have this capability to protect her. And I use this because this generation will relate to data in a totally different way as we do. They don't make any difference between a picture coming from space, coming from your mobile phone, coming from Instagram. So we'll have to think about that, about how we will implement things in the future, because for them it's totally seamless. If the GPS today on your phone is seamless for you when you move in and you use the Wi-Fi signal to position yourself, or the cell towers, you don't see it. It moves from one to the other. The same is happening with data today. You start to have this data economy, so we don't talk anymore about Earth observation, we talk about data, because it comes from everywhere. And this is the winner of a hackathon we did with SAP actually, in the World Mobile Congress 2 weeks ago. This is called Snap Planet, S-N-A-P Planet. You go on the iTunes store, you download it, you put your address, and you get the Sentinel-2 data of last week or the day before on your place. And it's beautiful. It's like this selfie from space my daughter were talking about, but it's much more exciting. What's happening, it's because it's put on a social media network, Instagram, but also a community level. People start exchanging views about these pictures. They start tagging the pictures. In the new version that will go out into 2 days, you will tag. There is an automatic tagging telling you there is sea ice, there is cloud, so it picks up from another data set of ESA. It knows there is cloud, so you will be able to sub-select all picture with cloud, ice, etc. And what's happening is that glaciologists start annotating these pictures, which are open data. And they say, this is this type of glacier, blah, blah, blah. And then another guy from a totally different community look at this and say, ah, but this I understand in context. So there is science going on with this app. It was not predicted. It's happening. Just because you're tagging, you share, and you have a community around it. And it's free. They want to make business, so business will come either by advertising. It's the platform economy. If you reach a number of users, you get already a commercial value. Thank you. So what's happening is that we are at the crossroad of a digital revolution and a sensing revolution, because the cost of technology is going down. And we have now a new microscope on the Earth, and it's also in Europe. The most comprehensive system is Copernicus, with this kind of mission called the Sentinels. Just to remind us, a sentinel is someone looking far away and warning us about something happening. There is not much difference between this and what happened 10,000 years ago when someone was doing a smoke signal, except that the technology enables now to see it from above. And you can see a lot of things from there. We are actually sampling the whole electromagnetic spectrum, optical with Sentinel-2, microwave with Sentinel-1, etc. And we try to bridge the last mile to user. Even Inuits are using SAR data, which is just amazing. Communities like this. And we have also open data from exploratory mission, which are complementary to the monitoring mission. They address specific questions for scientists and bring different pieces of the puzzle together. And then you have the new boys in town. All the guys who made money with internet, they are now very interested in space. No surprise there. That's where they invest to connect. Mark Zuckerberg's want people on Facebook, so he's sending drones, balloons, and also satellites to put 2 more billion people on it. Elon Musk is just changing everything in space, from the launch to the exploration of Mars. And other people are also in the business of launcher and tourism. Just on that one, these are the big guys. But what's happening as well is that you have small guys, startups of 4 people that are disrupting space because of the cost of technologies going down. So they can launch small sat. And you see here the trend. We come from the Envisat age, 10 tons, everything on one platforms, to a fully resilient distributed infrastructure that you do prototype engineering on the fly. You take technology from the mobile phone industry, so it's not a space at all. You inject it on a CubeSat, you see what it does. If it's not good, you tune it and you launch the week after. So that's the called agile engineering. So we are in this curve here, it's exponential. Our brain cannot handle exponential, we are linear thinking, okay? So I can take 10 linear steps, but I don't know what 10 exponential steps are. We are just at the beginning of this. So you've seen already the curve. Everybody is using a mobile phone these days. It's almost an extension of the body. So we are heading to cyborgs. So imagine if I do the same talk in 5 years, what I will be talking about. I don't know. This is totally unpredictable. It comes from industry which are lateral to our industry. You see, just to show you that technology is getting more powerful, but actually the opposite of this is that the cost is exponentially decreasing. So the barriers for entry are getting very low. And that's why we get bright people coming totally outside our community, disrupting it. And the challenge is for the open data to merge this data together. So we have this huge increase, space data. Copernicus is open by nature. We lobby a lot to make that happen because industry was afraid. Commercial data was high res, and we, of course, we go to high res, but they have to go to higher res even. Then you have open data on the web, 7 billion mobile phone, social media. So the guy who have the skills to integrate all this could actually be rich because they could create a lot of added value. And all this data is telling us that the Earth is under pressure, as you know. So that means that the demand for this information is also increasing. And that's why we need openness and transparency. This is a product we delivered months ago. It's called Global Urban Footprint. It's based on SAR data. It's a mask of cities all around the globe. It's a no-brainer. Is there a city? No city. It's based on backscatter of SAR. But there is a high demand for this because people couldn't define a city. If you talk to an economist, he gives you an index. If you talk to a mayor, another one. So the World Bank couldn't compare a city in Africa with a city in Latin America. Now they are using this to check the hotspot of change. And you see that we are already an urban species, but it's getting even worse. We are 50% of the population in the city. We had to 70%. And we see the pollution as well of this. So this is Sentinel to 10-meter resolution. This is the workhorse for agriculture. Transparency is really important here because there is a G8 or G20, I cannot remember. There is a big problem with the speculation on the market of crops. When there is an extreme event, for example, speculator also use that as an excuse to increase the cost. Okay? So you have a huge spike in the cost of crops, and your salad can go to 2 euros, but you might buy it. But the guys who have $2 a day to eat, it just doesn't eat. So one spike like this can put 20 million people in poverty, like this. So this G20 was trying to have more transparency in the market, so there is less speculation. And that's through the openness of data. So this mission will bring every week global coverage of the Earth land surfaces, and somebody is translating this into amount of crops. It's called GeoGlam, it's an initiative of Geo, so that we can understand how much food there is in the world and hopefully get more transparency. This is the speed of forest disappearance. And this is another example also to see crop with radar data. This works a lot for rice monitoring here in Asia. This one an example when we got El Nino and there was a drop of rice production. So in the interest of time, I leave you the slides. You know all this about the planet, all the indicators of change. We have the vital signs monitored by these missions, 50 parameters. We try to revisit the archive to have the best indicators. But the key thing is this value chain from data to information, and there we have a vibrant industry in Europe doing this. And what's happening is that the world is changing, so we are moving away from, I don't know who is using long-term records here? iTunes? Anyway, I'm on Spotify now. This is streaming. This is what we do with data. We don't care about ownership anymore. We just want access, we want real time, and this creates new business models. So that's what's happening in the data world. And we built laboratories like this, called the virtual lab, to enable scientists to access this without having the nitty-gritty of ICT. They don't care about it. And to compare different type of data. We also have, because of barriers of entry in technology, the ability of citizens to generate content for us, to classify our data. And this is an example of deforest action, where they adopt a part of the forest and they check every day if something is changing. And if it's changing, they send a team on site. This is another one where you put something on your iPhone and you get a map of aerosols. And this is called Picture Pile. You can download it as well. You have a pile of picture and a question, and you can say yes, no, maybe. So people classified. We gamify this, so there's a lot of community. So every company these days is a data company. Everybody's trying to go up the value chain. We are talking to SAP, which was in the database business. They go into the geospatial business. To BASF, which was in the chemical products. They now go into precision farming. So a lot is happening very fast. And so fast that these companies say, I cannot keep up with innovation in data. So I'm going to outsource this to startups. And they build corporate accelerators. So they pay for startups to stay in a place. These startups create content. The company takes equity. And the content goes on the platform of the company. This is very important because this is the way we do innovation these days with entrepreneurs. So at ESA, we try to create an equivalent pipeline where we have call for ideas like Copernicus Master, etc. The good one goes into incubation mode, then acceleration, and then we expose them to investors like venture capitalists, etc. So that might be actually the most disruptive business right now, this room over there. We don't know where it is. It could be totally out of space, so maybe it's your children, I don't know. So I take this as a almost concluding slide from Mr. Chairman. I mean, this guy, when he started to jump like this, his coach said, no, this will not work. And he did it, and then everybody started to do it, but he could do it because also there was a new technology that he could land safely. So why is that would? So that was a convergence of technologies actually, and the good timing, and it totally changed the way we look at this now. So this democratization of the data, of the technology, is also changing the way we look at this, and the role now of agencies like us is to enable this. It's not necessarily to build these tech; they exist. So I see ourselves as Gandalf trying to build communities together. So a kind of translational leaders. It's people who join dots, if you want. That's what I like to do these days. And this is another example of innovation about Sapuccino, but it comes from UK. So the Brits are really innovative on coffee. So I invite you and I put a challenge to you. Thank you.
That's the perfect conclusion, Philippe. I would say it's really an invitation
Thank
for
you,
the coffee
yeah.
break, this one. But maybe if there is any question
The
before.
proper path towards the coffee break.
Any question from the audience? Yes, two. I see two from both.
Okay. You're arguing that disruption is necessary. Is that a three-word summary of what you said?
Yeah, please.
I'm not sure I wanted to make that pitch. Disruption is there, so we have to live with it. We need to open our eyes. We need a mix of things. There are fast trains and slow trains. Slow trains are often more robust, but we need to listen to the signals in the environment. They are small signals, but they can grow big very fast. Say it again, please.
We need to enable this trust.
Yeah, no, we need in fact to build the highway on which people can build the restaurant, the little road, the services, etc. If we don't do that, we lose leadership position. And if we do that, we create innovation, we create jobs. So that's what we try to do with infrastructure, with data. We create platforms where we put all our tools, all our data. We pay for the cloud computing, so it's a public good. And we ask people with ideas to come and do some hacks on it.
Anna Maria Nassisi, coming from Thales Alenia Space. It's very nice your presentation, and I have done 1 year ago with Lewis student in business model by analyzing which is the possibility to well address the commercial market for Earth observation, and the demonstration of this is that the data sellers is old. The new issue is the application that you can find directly on mobile and so on. So this is a new idea that is disruptive for what concerns the Earth observation. My question is for what concerns the scientific community, which is the step forward. Is I see for educational is very, very important. But have you in your mind other benefit that we can have with this new approach?
Yes, actually the world is changing for scientists as well, and still we have these two trains. So we have the scientists like the explorer guys, they don't need new technologies, but the one who wants to exploit sentinels, they have to deal with 3 petabytes per year, so they will not download this on their disk. So they use these platforms, and by doing this we gain new advantages. First, we build a community around the tools and they share it. Second, we have full traceability, so they issue or they construct workflow, and we see exactly from the raw data to the product with the DOI, digital object identifier, the whole chain. And that creates new way of transparency. In fact, nature is actually moving on this with something called Jupyter Notebook. I don't know if you're familiar with this. It's a technology where by writing on a website, you interrogate a cloud and produce a result with a workflow. So you publish now in Nature, when you have a paper, you publish your paper plus your workflow, and people can verify what you do. So that's what we try to do with our platform. We want a traceability not only of the data, but of the whole value chain that the scientist is doing, so that someone else would gain trust, because the use of things depends on the trust. You would take, and we have seen this, you would take, if you have 10 data sets of CIs, you would take the one of your friend, not necessarily the best one, because you transfer trust to the use of the data. So by using these new technologies, we hope we can build a better trust because the whole community can review the whole thing. So it will be also there disruptive somehow.
So, thank you very much. Think there will be no more questions. Thank you very much, Pierre-Philippe. Of course, Open Uni the need is to clarify that Open Universe initiative is focused on a subset of data coming from the space activities, which is data coming from exploration and missions for the observation of the universe. But some best practices that Pierre-Philippe has presented us can be inspirational also for the exercise we have ahead of us, that is to see how the openness and the freedom of access to science data, to scientific astrophysics, planetary cosmology data can produce effects, direct and indirect effects on the economy and society. I think some ideas has come out from these discussions, from the very interesting presentation we have heard from our speakers. We thank you very much. Thank you to all who have helped us to search out for this session objectives. And I leave you with a Sat cafe, not cappuccino, but with a Sat cafe here near our bar in the facilities. Thank you very much.